Hello everyone! Have you ever wondered about that fine white powder used in chemistry labs? It's often potassium bromide, or KBR. Today, we're going to explore why KBR is so essential for a technique called infrared, or IR, spectroscopy. This technique helps scientists identify molecules by shining infrared light on them. But to analyze a solid, you need to hold it in something that the light can pass through. That's where KBR comes in, and we're going to break down the reasons why it's the perfect choice. The single most important reason is its transparency to infrared light. Think of it like a perfectly clean window for the IR beam. KBR does not absorb IR light in the most useful region for chemists, which is typically from 400 to 400 wave numbers. This means that when we get a spectrum, all the absorption peaks we see are from our sample, not from the KBR holding it. This allows for a clear and accurate analysis of the sample's unique molecular bonds. The second reason is that KBR is chemically inert. It's a very stable salt. It won't react with the vast majority of samples you want to analyze. This is crucial because you want to study your original compound, not a new substance formed by a reaction with the matrix material. Third, its physical properties are ideal for sample preparation. KBR is a soft, crystalline material that can be easily ground into a very fine powder. To prepare a sample, a tiny amount of the solid substance is mixed and ground with a much larger amount of dry KBR powder. This mixture is then put into a special press and subjected to very high pressure. This pressure causes the soft KBR crystals to flow and fuse together, forming a thin, transparent, glass-like disc or pellet. This pellet holds the sample particles evenly distributed, creating a perfect medium for the IR beam to pass through without scattering the light. However, KBR isn't perfect. It has one significant disadvantage: it is hygroscopic, meaning it readily absorbs moisture from the air. Water has very strong IR absorption bands which can interfere with the sample spectrum and hide important peaks. That's why KBR must be stored in a desiccator or a drying oven, and KBR pellets must be prepared and analyzed quickly to avoid contamination from atmospheric water. Finally, from a practical standpoint, KBR is relatively inexpensive and widely available, making it an accessible and cost-effective choice for labs everywhere. So, in summary, KBR is the star player in solid-state IR spectroscopy because it's a clear window for IR light, it doesn't interfere chemically, it's perfect for making sample pellets, and it's affordable, as long as you remember to keep it dry. Thank you so much for watching this explanation. If you found this video helpful and want to learn more interesting chemistry facts, please consider liking this video and subscribing to support the channel. Your support allows us to create more content just like this. See you next time.